I hope all of you are doing good. Let's start today's chapter, rational numbers. After reading this chapter, you will be able to know about all these topics. Okay, so let's get started. Introduction. We begin study of numbers with counting numbers which are 1, 2, 3 and so on. These numbers are called natural numbers. When 0 is included in natural numbers, they are called whole numbers. That is 0, 1, 2, 3 and so on. The negative of natural number along with whole number are called integers, okay, which we studied in chapter 1. Okay, see, these are the integers. We've also studied a fraction in earlier chapters. These numbers are in the form of numerator and denominator, where the numerator can be any whole number and denominator is a non-zero positive number. Okay, need for rational number. We know that when we add, multiply or divide two fractions, the result is a fraction, but it is not always true. Let us look at the following example. Okay, 1 by 3 minus 1 by 4 is equals to 1 by 12, but 1 by 4 minus 1 by 3 is equals to minus 1 by 12. This is not a fraction. Thus, difference of two fractions is not always a fraction, but it can be fraction with negative sign. Thus, we need to extend our knowledge of numbers. We also need to define a new set of numbers to represent the solution of equations of the type 2x minus 3 is equals to 2 or 7x plus 1 is equals to 0, etc. Now we define a new set of numbers which solve all the problems stated above. These numbers are called rational numbers. Rational numbers. Rational number is a number which can be put in the form p by q, where p, q are integers and q is not equals to 0. Thus, minus 11 by 4, minus 3 by 7, minus 2, 0, 1 by 2. These are all examples of rational numbers. We can have a rational number when numerator is negative but denominator is positive. Example, minus 4 by 5, minus 2 by 7. Also, we can have a rational number with numerator positive and denominator negative. Example, 2 by minus 3 and 4 by minus 7, etc. There can be rational number where both numerator and denominator are positive or both are negative. For example, these. Okay. Maths extension. The word fraction arises from the term ratio. Ratio can be written in fractional form, right? As you know, 3:5 will be 3 by 5. And remember, all natural numbers, whole numbers and integers are also rational numbers. Okay. It is also to be noted that all fractions are rational numbers, but all rational numbers may not be fractions. Okay. Equivalent rational numbers. A rational number can be written with different numerators and denominators which are all equivalent. For example, 4 by 5 is equals to, if we multiply this fraction by 2, then we'll get 8 by 10. Also, if we multiply this fraction by minus 2, then we'll get minus 8 by minus 10. And when we'll multiply 4 by 5 by 4, then we'll get 16 by 20. And if we multiply by minus 4, we'll get minus 16 by minus 20. So, these are all equivalent rational numbers. Okay. Thus, to obtain equivalent rational numbers, we multiply numerator and denominator of the given rational number by a same non-zero integer, either negative or positive. Positive and negative rational numbers. A. Positive rational numbers. A positive rational number p by q is that in which both numerator and denominator are of the same sign, that is either both p and q are positive or both p and q are negative. For example, all these are examples of positive rational numbers because minus 2 by minus 3 is 2 by 3 only and minus 3 by minus 7 is equals to 3 by 7 only. Okay. B. Negative rational numbers. A rational number p by q is said to be negative when either numerator or denominator of the rational number is negative. So, when either p or q is negative, the rational number p by q is called negative rational number. For example, these are all examples of negative rational numbers. Okay. Representation of rational numbers on the number line. We have already learned to represent natural numbers, integers and whole numbers on the number line. Just like integers, rational numbers are also represented on the number line. Positive rational numbers on the right of 0 and negative rational numbers on the left of 0. Let us see how to represent minus 2 by 5 on the number line. To mark minus 2 by 5 on the number line, we divide the unit segment OA into 5 equal parts. Okay. And students, also remember that positive rational numbers on the right of 0 and negative rational numbers on the left of 0. Always remember that. Okay. So here we have divided 0 and minus 1, we have divided this into 5 equal parts, and we have to represent minus 2 by 5. So we will not start from here minus 1 by 5, we will start from here minus 1 by 5, minus 2 by 5, minus 3 by 5, minus 4 by 5, and then minus 5 by 5. Okay. Clearly each part towards left of 0 represents minus 1 by 5. Therefore, the rational number minus 2 by 5 would be the second mark lying on the left of 0, that is OB. If a number is positive, it is marked towards the right of 0. Let us try to represent 7 by 3 on the number line. Since 7 by 3 is greater than 1, we first separate integer and fraction parts. So what 7 by 3 is 2, 1 by 3 means whole number, and this is the fraction. Now mark 3 unit towards right of what? 0, because this is positive integer. Okay. Since the number is greater than 2 but less than 3, the position between 2 and 3 is divided into 3 equal parts. Have a look. 2 and 3, the position is divided into 3 equal parts. Okay. Remember, number of parts are always equals to denominator of rational number. So each part is equals to 1 by 3. Now 7 by 3 or 2 whole 1 by 3 will be represented by this point P. Okay, on the number line. No more. 0 is the only rational number which is neither negative nor positive rational number. Okay. Next, rational numbers in standard form. Look at the following rational numbers: minus 5 by 3, 1 by 2, 3 by 4, and minus 4 by 5. Here first and fourth rational numbers have negative sign in the numerator, and there is no common factor of numerator and denominator except 1. Thus, they are rational numbers in the standard form. Thus, a rational number is said to be in the standard form if 1. Either it is positive rational number. For negative rational numbers, negative sign occurs only in the numerator and denominator is always positive. 2. There is no common factor between numerator and denominator except 1. Okay. Now, example, convert these fractions in the standard form. Okay. And so, what will you do? 2 by minus 3. You will multiply this by minus 1 and this also minus 1. So, minus 2 by 3. This is the standard form. Similarly, in this case also you will multiply numerator and denominator by minus 1. Okay. And if there is 16 by 36, what will you do? You will divide it by 4, you will divide it by 4. So, you will get 4 by 9. Okay. And similarly, minus 3 by 2, you will multiply by minus 1. Then you will get 3 by 2. Okay. No more. For reducing the rational number in standard form, we divide the numerator and denominator by the HCF, ignoring the negative sign. If negative sign is in the denominator, divide by negative HCF. Okay. Comparison of rational numbers. Number 1, two positive rational numbers can be compared in the same way as we compare two fractions. For example, 3 by 5 and 2 by 3. What will you do? First, you will find LCM. Okay, then you will make a denominator same. So 3 by 5, you will multiply by 3, and here also 3. 9 by 15, and 2 by 3, you will multiply by how much? You will multiply by 5, and here also 5. So 10 by 15. Okay, so 9 by 15 is less than 10 by 15. That is 3 by 5 is less than 2 by 3. Number 2. If one rational number is positive and the other negative, then it is clear that positive rational number is always greater than the negative rational number. For example, compare minus 1 by 2 and 1 by 2. Clearly 1 by 2 is greater than minus 1 by 2, because minus 1 by 2 will be in left of 1 by 2 number line. Okay. Number 3, if both the rational numbers are negative, then to compare them, ignore minus sign. Compare them and then change the order. For example, we have to compare minus 7 by 3 and minus 4 by 5. So first, what will we do? We will ignore the minus sign. Okay. Here we get 35 by 15 and here 12 by 15. So 7 by 3 is clearly greater than 4 by 5. So that means minus 7 by 3 is less than minus 4 by 5. Okay. No more. If A is greater than B, then minus A is less than minus B. If A is less than B, then minus A is greater than minus B. If minus 1 is multiplied to both sides in equation, changes. Okay. Number 4, to compare rational numbers which are not in standard form, we convert them first in their standard form and compare. For example, compare minus 2 by 3 and minus 3 by 5. So when we will convert minus 2 by minus 3 in standard form, we will get 2 by 3, and minus 3 by minus 5 will get 3 by 5 in the standard form, and then we will compare them as we compare in case 1. Okay. Rational numbers between two rational numbers. Can you say how many integers are there between minus 1 and 5? Obviously, they are 0, 1, 2, 3, 4. That is 5 integers lie between minus 1 and 5. Similarly, between 10 and 20, 9 integers, that is 11, 12, 13, 14, 15, 16, 17, 18, 19 are there. Thus, we see that the number of integers that exist between two integers is always finite. Okay, remember that. Can we say that if it is true for two given rational numbers as well? Let us see the following example. Between 1 by 2 and 3 by 2, try to find out all the rational numbers that exist. First, we write 1 by 2 and 3 by 4 with same denominator. Okay. So, we will make this denominator 4, 2 by 4 and 3 by 4. Okay, but there is no number between these two numbers. Now, what will we do? We will increase the denominator by any amount. You can increase it by any amount. Okay, multiplied by 10, and this also 10. You will get 10 by 20, and then you have this 3 by 4, multiplied by 5, and here also 5. So 15 by 20. Now, how many fractional numbers are between these two rational numbers? 11 by 20, 12 by 20, 13 by 20, 14 by 20. But what if we go on increasing the denominator? For example, in this case, denominator is 40. Now, there are how many numbers between these rational numbers? There are 9 rational numbers. Okay. Now, if we write 2 by 4 and 3 by 4 as 200 upon 400 and 300 upon 400, we can write 99 rational numbers between 2 by 4 and 3 by 4 and so on. Thus, it is clear that between two given rational numbers, there are like countless rational numbers. Okay. Example 2, find 5 rational numbers between minus 5 by 7 and minus 3 by 8. Okay, let's have a look. Minus 5 by 7 and minus 3 by 8. What you have to do is you have to make the denominator same. Okay, you can take any number. You multiply it by 8, minus 40 by 56. Okay. And then minus 3 by 8 multiplied by 7, and here 7, 21 by 56. Okay. So, we have to find out only 5 rational numbers between these two. So, you can write any rational number, okay, because there are many rational numbers between two numbers. Okay. So, you can write 39 by 56, 38 by 56, 37 by 56 minus, okay, minus 36 by 56, minus 35 by 56, and so on, because there are so many rational numbers between these two numbers. Okay. So, these are the rational numbers. Okay. Now, let's do exercise 9.1. Give 4 equivalent rational numbers for the following. Minus 2 by 3. You have to give equivalent. So, multiplied by 2, you will get minus 4 by 6. Then multiplied by 3, you will get minus 6 by 9. Then you will multiply by 4. You will get minus 8 by 12. Then minus 2 by 3, you will multiply by 5. Then you get minus 10 by 15. So, these are the equivalent rational numbers for minus 2 by 3. Okay. Next, operations on rational numbers. We have learned the addition, subtraction, multiplication, division of natural numbers, integers as well as fractions. Now, we learn to perform these mathematical operations on rational numbers. Number 1, addition. Addition of two natural numbers with the same denominator is rather simple. You know that very well. Okay. If the denominator is same, then what will we do? We will just add numerator and then we'll write the common denominator. Okay. Now, let us see how to add two rational numbers with different denominators. For example, minus 7 by 3 and 5 by 7. In this case, what will we do? We will first find the LCM of denominators and then write both of the rational numbers with the same denominator. Okay. So, here minus 7 by 3 and 5 by 7. LCM of 3 and 7 is 21. Okay, so we will make denominator 21, so we'll get minus 49 by 21, and here we will get 15 by 21. Okay, now we can easily add them up. Minus 49 plus 15 by 21. Okay, okay, now what will be the answer? Minus 34 by 21. Okay, subtraction. Subtraction of two rational numbers with the same denominator is simple as addition. For example, you have to subtract 4 by 3 from minus 5 by 3. So you will subtract only numerator and denominator will remain same. For rational numbers with different denominators, we follow the same procedure as for addition. For example, find the difference of two rational numbers, these two rational numbers. Now the denominator is different. So first we will find out the denominator, we will find out the LCM, then we will make the denominator same and then we'll subtract, right? Next, multiplication. Number 1, multiplication of a rational number with an integer. To multiply a rational number with an integer, we multiply numerator of rational number with the given integer applying proper sign. Denominator remains the same. For example, 2 by 3 into 5 is equals to 10 by 3. Okay, minus 3 by 7 into 5 is, you will multiply numerator by numerator, you will get minus 15 by 7 and so on. Okay, no more. Any integer can be written as a rational number. Example, 5 is equals to 5 by 1 or minus 7 is equals to minus 7 by 1. Number 2, all integers are rational numbers, but all rational numbers may not be the integer. Number 2, multiplication of a rational number with another rational number. To multiply a rational number with another rational number, we multiply the numerator of both rational numbers and denominators will be multiplied with denominator. For example, 3 by 4 into 4 by 3. We will multiply numerator by numerator, that is 12, and 4 into 3 is 12. So, we will get 1. Okay. No more. The rule for multiplication is A by B into C by D is equals to A into C upon B into D. Number 2, reduce this to lowest term and see B should not be equal to 0 and D shouldn't be equals to 0. Okay, now division. To learn division of two rational numbers, we first revise the concept of reciprocal, okay, which we have already learned in fraction. Reciprocal of 7 by 4 is 4 by 7. Reciprocal of 1 by 3 is 3 by 1. Reciprocal of 2 is 1 by 2. Okay. Similarly, reciprocal of a rational number is calculated in the same way. Reciprocal of 3 by 4 is 4 by 3. Reciprocal of minus 4 by 3 is 3 by minus 4. And reciprocal of 3 by minus 4 is minus 5 by 3. It is to be remembered that product of a rational number with its reciprocal is always 1. Therefore, product of minus 3 by 4 with its reciprocal, that is 4 by minus 3 is equals to 1. Okay. Similarly, product of this with its reciprocal is 1. Okay. No more. Reciprocal of a rational number A by B is B by A, where A and B are non-zero integers. Okay. And reciprocal of rational number is also called its multiplicative inverse. B, product of a rational number with its reciprocal is always 1. C, reciprocal of 0 is not defined. When 0 is divided, when 0 is returned in denominator, the rational number is always undefined, right? D, reciprocal of negative rational number is always negative rational number. And E, reciprocal, that is multiplicative inverse of 1 is 1 and reciprocal of minus 1 is minus 1, because minus 1 is equals to minus 1 by 1. So, reciprocal is minus 1, it remains same. Okay. Now, division of two rational numbers. Now, to divide a rational number by another rational number, we just multiply the first rational number by the reciprocal of the second rational number. Okay. So, what the question is? 7 by 9 divided by 3 by 4. What will we do? We will do the reciprocal of this fraction, okay, rational number. 4 by 3. Okay, now 7 into 4 is 28, 9 into 3 is 27. Okay, similarly, minus 3 by 8 divided by 1 by 2. Minus 3 by 8 into 2 is equals to minus 6 by 8. Okay, or you can also convert it into simplest form, that is 3 by 4. So, minus 3 by 4. Okay. additive inverse of a rational number. As we know that the additive inverse of an integer is the same integer with opposite a sign, like additive inverse of 5 is minus 5 and additive inverse of minus 10 is 10. Similarly, additive inverse of a rational number is a rational number with opposite sign. For example, additive inverse of 2 by 3 is minus 2 by 3. And additive inverse of minus 3 by 4 is a 3 by 4. Similarly, additive inverse of minus 7 by minus 8 is what? Minus 7 by 8, because these two signs will cancel out, okay? And similarly, because minus 7 by minus 8 is equals to 7 by 8, therefore additive inverse is minus 7 by 8, okay? When a rational number is added to its additive inverse, we get 0, okay? No more. Additive identity of rational number is 0 and multiplicative identity is 1. Always remember that, okay? Now you have to find the sum of the following, okay? 1 by 3 plus minus 2 by 3, okay? Denominator same. No need to find LCM, okay? So 1 minus 2 is minus 1 by 3 is the answer, okay students? Now you will do practice of the remaining questions.